Today I'd like to talk about self-controlled traffic flow and what are the benefits. You've probably heard about phantom traffic jams, and this is basically coming from systemic instability, so small perturbations in the flow are basically amplified, giving rise to a domino effect. And in cities, things are even worse because cities are based on network interactions, and you all know these terrible traffic jams that are actually forming in many places. However, there is hope, and actually, the innovative self-control approach that we have developed was inspired by an observation that I made in Egypt. And as you can see over here, we have an intersection without any policemen or traffic signals, and still it seems to work well. So it's self-organizing, despite the diversity of different traffic participants. And I figured out that the reason for this was that it had a particular design which enabled people to adapt in such a way that everyone would find a gap in the traffic flow that had to be crossed. And we eventually developed this new self-control approach for traffic lights, which basically works very much different from what we do today. Rather than trying to control the traffic flows, we let the traffic flows control the traffic lights. So we turn around the control principle, and it has been inspired by another observation, namely of pedestrian flows at bottlenecks, where we find oscillations of the flow as if there was a traffic light. But there is no traffic light, and in fact the oscillations come about by a variation of the pressure in the crowd. And so the idea came up that we could actually that the traffic flows control the traffic lights. That means we could define a pressure principle based on demand that would turn traffic lights red or green. And so what we do is basically we are measuring in various ways not only the outflow from road sections, but we measure also the inflow. And that allows for a very short-term traffic prediction, and considering that allows us basically to do a phenomenal job, as we'll see in a minute, just based on real-time feedback to these anticipated values of traffic demand. What we've done is we have compared at least 3 principles of traffic light control. One based on a central control center, which basically tries to collect as much data as possible and to come up with an optimal plan, like a benevolent dictator. But it turns out that traffic light optimization is an NP-hard control problem, and basically in a reasonably sized cities, even supercomputers cannot do it perfectly. So you need to make simplifications. And therefore we have tried out decentralized approaches, where the traffic lights respond to the traffic flow just in the neighboring street sections. And that implies that every intersection is trying to do the best job it can do, but there's no coordination between neighboring intersections. And the third approach, which we call other regarding coordination, is actually paying attention to the neighboring intersection. Not more than that, but this enables coordination between the intersections and the traffic flows over there. And as you can see over here, the results are very promising. The red line corresponds to the top-down control by the traffic control center. And so you see that the queue length of vehicles increases with the capacity utilization, basically the traffic volume. However, if you look at the blue line, then it turns out that this other regarding approach, that was the third one that I mentioned, actually reduces the queue length dramatically by flexibly adapting to the actual traffic situation in the neighborhood. And so we can say that bottom-up self-organization can outsmart optimal top-down control attempts. And this sounds unbelievable, and so we put it to the test. In particular, we did that in Dresden, where I was professor for some time. And you can see the area of the city that was concerned. It's in the center of Dresden. And in fact, it's the most complicated area. Of course, they have been buying the most advanced state-of-the-art software to control the traffic flow. This software produces green waves and it's also adaptive, but they couldn't prioritize public transportation, which they wanted to do. But if they did that, basically this interrupted the green waves and it destroyed the flow in such a way that a monster traffic jam would come up quickly and it would stay there for hours. We've been able to come up with a better approach, which is benefiting not only cars, but also benefiting public transportation, pedestrians and cyclists, and also the environment. That means nature is benefiting too. And this has actually been evaluated independently, and I would say even secretly, by another institute. And it came to really very strong results. It showed that this approach is much better than what was available before. We are now talking about another city, a city in Switzerland called Lucerne. And there were newspaper reports about it. So they say, thanks to the super traffic light, everyone needs to wait for a shorter time period. More green for everyone. And here you can actually see the effectiveness of this approach. So on top you see a lot of red, which corresponds to the traffic jams forming behind the red lights. On the bottom is what you get with the self-control approach. That means a lot less waiting of cars. And so protecting our environment can actually benefit everyone if we just do it the right way. There's actually a patent for this, which can be licensed also in India. And the very same principles can in principle also be applied to logistics and supply networks to make them more effective. Because many of the problems in supply networks and logistics are very similar to the traffic jams that we've been talking about before. Actually, we have been working together with Infineon, which is a wafer production company that you probably know. And we have found that there was a slower, faster effect. That means we came up with a new way of scheduling the process that made actually the production process more than 30% more efficient, something that was almost unbelievable. And so basically we want to apply that also to make the world more sustainable, actually with a new socio-ecological finance system that we call Fin4. And so everyone knows that we need to turn wasteful supply chains into a circular economy. The question is just how. And here basically the Internet of Things comes to our rescue if you would just use it in a participatory way. So the idea is to again get real-time data and create real-time feedback. So to map collectively in a participatory way noise, CO2, emissions, poisons, and all other externalities, also good things, and then basically create a feedback. We've done that also for air quality. The feedback should make sure that positive externalities are increased, negative ones are reduced, and fair compensation is ensured. And so basically this approach is combining all sorts of measurement methods with new kinds of money, actually not just one kind, but many kinds. So it's a multi-dimensional feedback and incentivation approach that would introduce new forces into the markets and into the economy that would little by little lead to improvement of the production processes and logistics, such that eventually by a co-creation process and a co-evolution process we would get towards a circular economy. So in summary, we need solutions that acknowledge and embrace the complexity of systems. We cannot control everything top-down, and particularly not complex systems that are made up of heterogeneous elements, behave differently, there's a large degree of fluctuations, short-term predictability, actually all properties that apply to a lot of systems around the world today. These are the problems to be addressed, and actually I've just shown you a revolutionary new approach that allows to make a much better job than we've been able to do in the past. It turns also out that if we compare that with machine learning approaches and AI approaches, this approach actually outperforms. So that is something that actually Marcin Koretsky will be talking about just in a minute. He is the superstar who is actually trained in machine learning and AI and figured out that things can be done much better in complex interactive systems such as traffic systems that are creating a hell of a mess and a lot of congestion and bad air quality and poor quality of life today. But all of that can be changed, and we're also now working on an approach that would allow to satisfy multiple goals, such as short travel times, little congestion, better air quality, better environmental conditions. Without further ado, I'm handing over to Marcin.